Hey guys, welcome back. In this video, we'll be covering if statements. So if you haven't watched the Boolean type, this is a very important concept in this video. So please look at the previous video on Boolean types. Otherwise, let's get started. So if statements, the syntax is pretty simple. So what you have to do is write if followed by a condition. Right? And this condition has to be expressed as a Boolean type, right? So whatever you calculate in the expression, it has to return either true or false. And based on this, the if will execute either the block associated with it or not, okay? So if a Boolean expression followed by a colon, and when you press enter inside the editor, our IDE editor, then it will automatically put an indentation. Normally, an indentation is 4 spaces or 1 tab, okay? So keep that in mind. So basically a block is an indented sequence of statements, and if this expression is true, what if statement does is execute this block, right? But if this expression is not true, then it will skip whatever you have inside this block. It's a conditional execution. And if statement do comes with some optional. So for example, you can attach additional conditions. So they are attached with else ifs. So in Python, the syntax is elif, and then you can attach additional expressions. So what's going on with this is that if this original condition is false, then it will move on to the next else if condition, and then check whether that's true or false. So you can attach as many else if as possible, and if any one of those conditions are true, then the associated block will be executed. And finally, if all those expressions fail, but you still have some dedicated code that you want to run with whatever you have in the function, you can attach an else. Okay, so else is when all the conditions above have failed, then the else block will be executed. So this is the nutshell of how the if statements gets executed in Python, and the same concept really applies in any other language as well. So here, both else if and else, they are optional, so you can still write if condition and block and leave it at that, where the program will determine whether to run the block or not based on the returned value in the Boolean expression. All right, so let's have a look at an example. What we're going to do is use a quadratic roots function. So you know the formula negative b plus minus square root of b squared minus 4ac divided by 2a, and that's what we're going to calculate here. So this is the formula here, and we just have to calculate the value to be returned. Okay, so first we calculate the determinant, which is b squared minus 4 times a times c, our determinant here, and then we need to apply negative b plus minus. Okay, so root 1 is at negative b plus our determinant. You have to square root it, and to square root this, we're going to use a math module. We will cover more about importing modules and using it soon, but essentially think it as like math has been imported and math has its own functions associated with it. One of them is square root, so we're going to use that. Okay, don't worry too much about the syntax for now. And then divided by 2a. So this equation is literally just one version of this using plus, and then the next one is using the minus. Okay, so that's what we want to do. Okay, so I have that written up here. Where is it? Here it is. Okay, quadratic roots, run it. Okay, so now the name quadratic roots has been loaded, and we can check 1, 2, 3. It's giving me a value error, math domain error, probably bad numbers. I should have done something like 4, 8, 2. Okay, then it's going to calculate me the values for x, which are at negative 0.29 and negative 1.7. But obviously, as we've seen in this particular example of 1 to 3, that it can't handle some values, right? So here in the next slide, we have more examples. So here, another one is 112 x squared plus x plus 2 has no real solution. And therefore, Python will throw an error, okay? So we just saw a value error, math domain error, same as here. Okay, so we double check that with 112, 112. Okay, and here we have the same. Basically, when we try to calculate root 1, it fails. Okay, so we cannot calculate this value. So we need to capture those through different conditions, because we already know that certain values shouldn't be less than 0, for instance, right? So for example, if the determinant is less than 0, this is where our equation will fall into no solution, no real value solution. So we can capture that using the if condition. So write if determinant is less than 0, then we can print no real value solution, and then adding a return will escape the function that we're running before executing any other code below. Okay, so that's one way of early quitting the function, which is exampled here. Okay, so this example is here. So we run this again. I have the quadratic 2. Okay, here 1, 1, 2, and in this instance, I have name error. I need to actually you need to have the determinant assigned before the if statement. Okay, don't make the same mistake as I do. Save, run. Okay, run it again. Okay, now I don't get an error. I can continue with my function or the program saying that there is no real value solution. Okay, so this way, what we can benefit from is that the program will not crash, which means if you had more calculations after that based on the returned roots, then I can continue calculating by capturing this specific scenario where I had no real valued solutions. Okay, so this works, which is good, but the solution isn't very intuitive and clean. So what we can do is improve our solution using some of the additional blocks that we can add onto the if. Okay, so to make this much better and clear, what we can do is group the rest of the code into the else block. Okay, so the syntax is as shown before. If there's an expression, statement 1, else the other statement. All right, so by reformatting our current code into if and else blocks, it will look like this. So basically, we calculate the determinant, and then if the determinant is less than 0, we can print this out. Else, we can calculate it and then return the roots better. So this way, we don't have to do a return statement inside an if block. Normally, it's better not to do any returns in if statements, but for now, we will stick with this. So our next version is here. Check that this is working, 112. Okay, so this is working, and then we can also check with our previous example 482, and the values are the same. So we can double check that this is working, and it is a bit more intuitive than our previous example, saying that if it's 0 less than, if the determinant is less than 0, we have no real solution, but otherwise we can calculate it and then return both of them. But we have one more problem. What is that? What could be? So if you sneaked into the next slide, you know that if our quadratic roots have a solution but converges to a single value, for example, if we pass in input parameters 1 to 1, then we have -1 as a solution, it will still return it twice. Okay, so we don't want it to do that, so we're going to capture this scenario as well. Okay, so here is an example code that you could use to capture those scenarios. Basically what it's doing is, if we still have this if determinant is less than 0, then we have the no real value solution that stays the same. And if we do have the real value solution, the single value only happens if we have determinant equal to 0. So if it is 0, then I can calculate only one root and then return the root. Otherwise, I can calculate both roots and return it. So this way, our current solution 1, 2, 1 returns both -1s, but we have our next one, quadratic 4. This way, I only have to return -1 and still function the same by returning two roots if there are two roots in this instance, and of course, no real value solution if we don't have real solutions. Okay, so by adding on extra checks inside any one of those blocks, in this case, inside the else block, we have created additional if block here. We can check additional conditions. However, we can probably do better by using the else if conditions to make the indentations less. Because if you remember the style guideline, you cannot have more than 4 indentations in your function. Okay. So our alternative solution using the else if looks like this. So this is actually a more cleaner solution where if our determinant is less than 0, we know there's no real value solution. Fine. Else if determinant is 0, then we have only one root. Else, we know at this stage we have two roots, so we can calculate two roots. Okay. So without increasing the indentations, here is our root 5. We can handle all the scenarios now, and the code looks much clean and neat. Okay, so check 1 to 1, that returns -1. We can 1 to 0, 0 and -2. And if we do 3, then there is no real solution. So as we can see, all those codes that we have covered here does pretty much the same thing. However, the way we structure it can vary a little bit, right? So that's an example of running over calculating the roots. So let's have a look at the flow diagram aspect. So exactly what controls are being called and happening when we go through those blocks, right? So this one also comes with the code. However, you're welcome to pause and try those codes as well. So this one is taking an input, and basically it's going to convert it into a float number to check whether the pH level is acidic or basic. Okay, so for starting with if pH is less than 7, basically substance is acidic, so we can say the substance is acidic. And then what's going to happen is that we grab an input, and what's happening with the if block is that it looks like this, and check whether this condition is true or not. If this condition is true, it's going to sidetrack from our main body of the function and carry out the if block code. So if we have more codes here, then we're going to have more tasks outside here, and then returning back to the main line of body of the code. Okay, so now we have two prints inside this if block. That means I have a lot more code for acidic case. Okay, so now we're going to attach the else part. Then our diagram will change like this. Basically, we still have the main block code, but this one is part of the else. So here, yes, that means we execute the code for if, but no, we execute the code for non-acidic case. So this condition has failed, then I'm moving into in this block, and that can be represented as a flow diagram on this side. Okay, we can also include a neutral case where pH is 7. Then the diagram will look like this. Okay, so first it checks whether pH value is less than 7. Okay, if this is true, it will have its acidic case code. But if it's false, it will move on to the else if condition and check whether pH value is 7 or not. If this is true, it will execute its code for the neutral case. And if finally, if that is false as well, then it will move on to the base case. So you can see that out of this flow diagram, it will only execute one of those blocks. Okay. So this is clear that if conditions can decide based on what expressions we're evaluating to select a specific code to be executed as necessary. Okay. We could, however, rewrite only using if blocks as such here. So for example, if pH is less than 7, we can print this. If pH is 7, then we have this. Also, if it's greater than 7, we can print this. This only works because we don't have any overlapping regions of conditions. For example, pH values cannot be falling into this block as well as any one of the other blocks, and same for any combinations of those blocks. So pH values are mutually exclusive to start with, and therefore we can construct this if block using 3 different if blocks, and we won't have a problem. But obviously this doesn't work for all the other cases, so you need to be careful and check whether your flows will not be overlapping. Okay, if we draw this diagram, it will look like this. Okay, we will execute this and then come back to the main body, and basically it will check all the conditions, whether that's true or not, to check to execute the code for that specific if block. So we have some advantages and disadvantages for this. Basically, this is a little bit more flexible. However, in that sense, there's not that much flexibility gained by doing so. It is explicit about when each block gets executed, so you can see exactly at which stage of the program when this if block will be executed or not. Okay, but those benefits are actually not enough to overcome the disadvantages, which are that does not make the mutual exclusion obvious. Your logic has to be clear and mutually exclusive to ensure that a single input value does not fall into multiple if blocks. And also this is slightly less efficient, although it is not a main concern of this unit, but you can see that it's going to do 3 if statement checks. Even though if pH was less than 7, in our previous examples, it only does 1 if statement, but here it's going to do 3 if statement checks. Okay? But don't worry too much about the efficiency. These are really minor. You rather improve on your algorithms and its complexity, which you can discover more at CITS2201. Okay. And finally, this is a note about float point comparison. So I believe I covered a little bit when we were doing the Python basics, but if you're dealing with float points, never ever compare them to check whether they are the same value or not. So here's an example. So a equals a equals 3 times 1 divided by 3. So you can see it's 1.0. Okay. Oh, no, not times 1. 0.1, 0.1. Okay. So a is 0.1. But here already you can see that it's got a bunch of zeros and 2 at the end because it cannot calculate the exact value. So if I say if a equals 0.1, print yes, else print no, then obviously we're going to see no. Okay. And you can check this by running some code like this here. So you can try this yourself. And there will be some cases where the equality will return true as you thought, but many others it will be not true because the float points cannot be stored exactly in computer due to its binary nature. Okay, so the keynote is never compare floats for equalities or inequalities because they don't have the exact value stored. Rather, floats are approximate, so equality cannot be guaranteed, and keep that in mind. Okay, so that's it for this video about if conditions. Structuring if conditions is not too difficult. It just comes with if, else if, and else block. So it's all about how you logically arrange the conditions and put which code to be executed in which block. So next up, we're going to be looking at logics. I'll see you in the next video. Bye.